Okay, this is for section 5.1 using fundamental trig identities. So the reciprocal identities, quotient identities, and Pythagorean identities we have discussed before in section 4.3. So we've gone over these, we used them in chapter 4. This is just kind of a review at the beginning of this section. And in all of these identities, the book has used a U, but a U can be changed to an X, a theta, any symbol you want. It doesn't matter what that symbol is. It just represents an angle. So the reciprocal identities, we've learned that sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals, and tangent and cotangent are reciprocals. So those can be replaced with each other throughout an equation. The quotient identities are for division, so we know that tangent is equal to sine divided by cosine, and therefore cotangent is cosine divided by sine. The Pythagorean identities we actually proved in section 4.3 where they come from Pythagorean theorem, but they can be used interchangeably, and you can rearrange any of these three to also have another Pythagorean identity. So these can be used in various formats. The next set of identities are new, the cofunction identities and the even-odd identities we talked about before also. With the cofunction identities, don't get worried about what they mean, that the sine of pi over 2 minus u equals cosine of u. Don't worry about what that means right now. Just memorize that the left side equals the right hand side. And when I see this, I know it is equal to this. Later on, we're going to get into what the actual meaning of pi over 2 minus u is and why they are cofunctions. The even and odd identities, we learned early on that the cosine and secant functions are even identities and the other four are odd. And the reason for that is that the sine or secant of a positive angle or a negative angle have the same function value. But for sine, cosecant, tangent, and cotangent, a positive angle and a negative angle have opposite values. Okay? But for right now, just memorize the left equals the right. Okay, so we're going to get into our examples. Example 1 says to use the information that's given to find the other 6 trig functions. Well, since they've given us 2, we just have 4 left to find. On these problems, you can use your unit circle to find any answers that might be on your unit circle, or you can even draw a triangle and label it with the information that's been given. So they gave us that the secant of some angle is equal to the square root of 2, and that the sine of the same angle is equal to negative square root of 2 over 2. So if the secant is square root of 2, then I know its reciprocal, cosine. So to get the cosine, I'm going to take the secant value and flip it. So square root of 2 is the same as square root of 2 over 1. So when I flip that over, that becomes 1 over the square root of 2. I can't leave a square root in the bottom, so I'd have to multiply top and bottom times the square root of 2 and simplify, and that will give you square root of 2 over 2. So the cosine of this angle is square root of 2 over 2. Same thing for the sine. If I know the sine is negative square root of 2 over 2, its reciprocal is cosecant. So I'm going to take the sine value and flip it over. So this just becomes negative 2 over square root of 2. I like to keep my negatives either up top or out to the side. Don't put them on the bottom. Since I have a square root in the bottom, I need to multiply top and bottom times the square root of 2 again. So this time, this is going to give me negative square root of 2, or negative 2 times the square root of 2 over 2. The 2 in front of the square root and the 2 on the bottom are going to simplify and reduce, so your final answer for cosecant is just negative square root of 2. Okay, now for tangent. We've learned that tangent is sine divided by cosine. So if I take the sine value that I have and divide it by the cosine value that I found, negative square root of 2 over 2 divided by square root of 2 over 2 is going to simplify, and this is going to equal negative 1. So if I know the tangent of this angle is negative 1, the reciprocal of tangent is cotangent, so the reciprocal of negative 1 is also negative 1. So in the end, you should have 6 trig functions. If they gave you 2 to start with, then you have to solve for 4. Okay, example 2, and all of the rest of these examples are going to be simplifying the trig expression using the identities. And our goal when we simplify is try to get things in terms of sine and cosine in as few terms as possible. Okay? So this first one, you have secant x times cosine x. So I want to take this secant and I want to replace it with something that it's equal to. So we don't want to get into complicated identities. We want to use kind of the basic ones, or what's as simple as possible. And I know that secant is equal to 1 over cosine. So I'm going to replace secant x with 1 over cosine x. And this is still being multiplied times cosine x. So if I have 1 over cosine x times cosine x, these cosines are going to cancel, and I'm just left with 1. So this identity, secant x times cosine x, actually simplifies to 1. So 1 is my answer, but I want to make sure to show my work and the steps that it took for me to get there. There are lots of different ways that I could have simplified this and still gotten 1. Make sure you're showing your work. Okay, number 3, same thing. We want to simplify the expression. So this one has secant squared x minus 1 over sine squared x. So if I'm not sure where to start, I see that I've got a secant squared and a sine squared. Well, in the identities, what triggers my mind is the Pythagorean identities, because I know they have squares in them. So I look at my Pythagorean identities. I'm going to do a little bit of work out to the side over here. And one of my Pythagorean identities says that 1 plus tangent squared theta is equal to secant squared theta. So I could go ahead and substitute in for secant squared into this equation, and that would work. Or I'm going to rearrange my Pythagorean identity to help me out. So if I take this Pythagorean identity and I subtract 1 on both sides, this will give me tangent squared equals secant squared minus 1. So this is still a Pythagorean identity. I've just rearranged it to help me out in this situation. So in place of secant squared x minus 1, I can substitute using this Pythagorean identity, and I'm going to put in place of it a tangent squared x. And then we're still being divided by sine squared x. Okay, so now I'm going to take this fraction and I'm going to split it up into 2 pieces. Tangent squared times 1 over sine squared. Okay, so now that this is separated, I want to see if I can replace tangent squared with something that's it's equal to make things simplify a little further. Now, I could kind of go back over here and use this same Pythagorean identity, but that's just going to get me back to where I started, so I'm not going to use that again. So I think about the relationship that tangent has to sine and cosine. And I remember that tangent is equal to sine divided by cosine. So that also means that tangent squared is equal to sine squared divided by cosine squared. So I'm going to replace tangent squared with sine squared over cosine squared. And this is still being multiplied times 1 over sine squared. So now you see that I've got a sine squared on the top and a sine squared on the bottom. Those are going to cancel out. Then I'm just left with 1 over cosine squared. So some people would say that this is as simplified as this will get, 1 over cosine squared. It's in terms of sines and cosines. But other people would probably say, nope, it's a fraction. You can simplify it further. So 1 over cosine squared is fine with me, or 1 over cosine squared is also going to be equal to secant squared. So either of those to me would be a correct answer if you can get to either of these places. I don't think one is any more right than the other, but different math professors would say that secant squared is more simplified than 1 over cosine squared. Okay, number 4 says sine phi, just another Greek letter like x or alpha or theta or any letter I put there. Sine of phi times cosecant phi minus sine phi. So what I want to do is, first thing is replace this cosecant with something that it's equal to. Remember, get things in terms of sines and cosines. So I'm going to leave the sine phi out front, and then I'm going to replace cosecant phi with 1 over sine phi, and then minus sine phi. Okay, some people would think you probably need to subtract the two things in the parentheses first and then multiply it times the sign outside. If you did that, you'd have to get a common denominator and it's going to get a little messy. But if I distribute first, some nice things are going to happen. So if I distribute sine times 1 over sine, that's the same as sine divided by sine, which is just 1. Okay, then when I distribute sine times negative sine, that's going to be negative sine squared. Okay, so that's good. I've gotten rid of a few things and I've got it down to 2 terms. Well, I've seen this sine squared before in the Pythagorean identities, so out to the side, I'm going to find that Pythagorean identity that has sine squared. It says that sine squared plus cosine squared equals 1. So I need to figure out how this can help me in this problem here on the left. So if I rearrange this Pythagorean identity by subtracting sine squared on both sides, then cosine squared is equal to 1 minus sine squared. It's still a Pythagorean identity, I've just rearranged it to help me. So in place of 1 minus sine squared phi, I can substitute cosine squared phi using that Pythagorean identity. Now I've got this whittled down to 1 term that's as simple as possible. Okay, last one says to simplify the trig expression again using the identities. So we've got cosine of pi over 2 minus x times secant x. So a lot of people would think, oh, I need to distribute the cosine into the parentheses. This is not a distribution problem. This is cosine of x, or pi over 2 minus x is one angle. Okay, it's not 2 separate things. So remember, this is part of those identities from the beginning of this lesson, those cofunction identities. Don't worry about what it means, just remember what it equals. So this cosine of pi over 2 minus x is equal to sine of x in the cofunction identities. Okay, and then I'm going to look at secant x, and I want to see what it is equal to. So secant x, the simplest thing that it's equal to is just 1 over cosine. So now sine times 1 over cosine is just sine over cosine. So I could leave it just like this. It's as simple as it can get. I mean, it's in terms of sines and cosines, but I've got 2 terms. Maybe I can write it into just 1 term. So I remember that sine over cosine is equal to tangent. So this is more simple, even though it doesn't have sines or cosines in the answer. It's 1 term instead of 2 terms. Okay, so your homework is on page 379. You're doing 2 through 58, every other even.